Assalamualaikum warahmatullahi wabarakatuh to all my fellow students. Inshallah today we will move to our next chapter, which is the last chapter for our subject, physical chemistry. So for this chapter entitled Introduction to Quantum Mechanics or Quantum Chemistry, when we talk about quantum is something that we will discuss something small, extremely small, up until atomic level. So as we know that in our world, in our environment, it consists of a macroscopic object. So the object is a large object, and so it contains a small object, extremely small object. So what kind of macroscopic object? Kind of a planet, a matters, a particle, motion, car, aeroplane, something like that. So all of this motion we can predict well. We can predict by using a certain formula, certain mathematical equation, because this is physical behavior. And then for microscopic objects such as electrons, such as light, still we can predict it. However, we need to use a slightly different method or slightly different analogy, just slightly different mathematical theory to explain all of this motion. So both of it have a different approach to predict or to describe the behavior of the properties of each other. So that's why we are going to see what is different between these two, what is the limit between these two, and to exploit. If we go to textbook or if we go to another explanation in YouTube and so on and so forth, we will come through with a lot of mathematical equation to describe everything, because to prove what we want to say, we must learn how to derive all of this equation. However, I will not scare you to prove all of those. I just give you a little bit of introduction how we will use all of this equation, and why. I just give a simple equation, the equation that we will use, and not to derive it. Otherwise, it will become another subject. Okay. As we know, there is Al-Quran that mention about this atom. وَمَا تَكُونُ فِي شَأْنٍ وَمَا تَتْلُو مِنْهُ مِنْ قُرْآنٍ وَلَا تَعْمَلُونَ مِنْ عَمَلٍ إِلَّا كُنَّا عَلَيْكُمْ شُهُودًا إِذْ تُفِيضُ فِيهِ وَمَا يَعْزُبُ عَنْ رَبِّكَ مِنْ مِثْقَالِ ذَرَّةٍ في الأرض ولا في السماء ولا أصغر من ذلك ولا أكبر إلا في كتاب مبين. أو Muhammad, you are not engaged in any matter or recite any of the Quran, and you people do not do anything except that we are witness over you when you are involved in it, and do not absent from your Lord is any part of an atom within the earth or within the heaven or anything smaller than that or greater, but it is in a clear register field. I would like to try to extract intention between this ayat. مثقال ذرة. مثقال ذرة. And we also see this ayat of Quran in Juz 13. وَمَنْ يَعْمَلْ مِثْقَالَ ذَرَّةٍ خَيْرًا يَرَهُ وَمَنْ يَعْمَلْ مِثْقَالَ ذَرَّةٍ شَرًّا يَرَهُ. مثقال. So this Dharah, small particle, is already mentioned in the Quran almost 1,400 years ago. It's already mentioned about it, and you can refer this in the Quran in Surah Yusuf, verse 61. before 1911 or early 19th century, the scientists thought that the atom was the smallest indivisible component of matter. However, this is not true because later on this theory evolved, the atom theory evolved, and we learn about Ernest Rutherford model of atom. He's mentioned about this atom. The atom particle are composed of electron, neutron, and proton. And his theory become the foundation of a modern quantum theory. When he got this theory, later on we will see why physicists and chemists see why the behavior of this electron or this proton or this atom is differ from that foundation or the code that we have before. It is because of this electron containing of its electron, neutron, and proton, and all of these particle or subatomic particle have their own properties, and we will see later on what is the properties. And as I mentioned earlier, we can using this quantum or quantum mechanics theory to understand the behavior of a system that we would like to study at the atomic level. As for your information, I did my PhD in quantum chemistry or computational chemistry, where I learned a bit of quantum mechanics theory or quantum chemistry theory. So I would like to share with you what I did when I do my PhD. Now, the first is by using this quantum mechanics theory. We can predict or we can reveal the behavior of a system. So for example, in this paper, selective formation of an iron 4 oxide or an iron 3 OH. Support intermediate from iron 2 and oxide, control hydrolytic versus homolytic oxygen more cleavage by the second combination. So here in this paper that we try to reveal either this system, this iron 4 system or iron 3 system is better when it's better to control the heterolytic versus homolytic oxygen bond cleavage. So by using this quantum mechanics theory, because this one is the atomic levels, atomic scale. So to reveal the theory, we need to use a quantum theory where computational chemistry is one part. How to do to reveal the properties of the system. So from there, we can reveal how the system is interact when we give hydrogen peroxide. So according to that, according to this research, we demonstrate that the device incorporation of an alkyl amine group into the second combination sphere of the system allow to switch its reactivity with hydrogen peroxide. So this is the thing that are important when we reveal this system. And then here is another work that I did where we try to reveal the galactic mechanism of aromatic nitration by cytochrome P450 PXTE, involvement of a ferric nitrate intermediate, where in the system we see we try to reveal the pathway of the aromatic nitration process. So, and then from there we determine that this pathway is the best one, and from there the experimentalists are able to proceed or to further their work. Well, I think this one is an next paper or nice information where not so many people discover, or not so many people are trying to reveal this mechanism, where it takes a longer time to do so. And later on, here is an example where I did another work. This study, we are trying to reveal how the vanadium peroxidase generate hypochlorite from hydrogen peroxide and chloride. Here we did a correct study where this vanadium peroxidase is one of the enzymes that is abundant in the sea. And then we try to reveal the mechanism of the system. So this enzyme will utilize this hydrogen peroxide, and then it will turn it into superoxo species. Later on, it will when we introduce halide either chlorine, chloride, bromide, or iodide, it will release the HOCl or hydrochloric acid. So for this enzyme, is can be used as antibacterial, yeah. And then here is a few things that we did, where this one is 3 years work, where we tried a lot of things to reveal the properties of this enzyme. And here is another work where we try to know the reactivity pattern of vanadium 4 and vanadium 5 oxo complex with olefin in the presence of peroxide. Here is how I use the quantum mechanics theory to do my work and to complete my study, where by using this quantum mechanics theory, we are able to see, or we're able to understand better the system, and from there we are able to design our own enzyme, try to mimic this natural enzyme, and from there we can devise, or can try to synthesize our own enzyme that is more or less efficient as our natural enzyme.